Yes, sounds on. Okay, let's continue for the second talk. Thanks for all being here. This talk, as the title says, we'll talk about a new development within the Spring ecosystem where we can use GraalVM to compile our applications to native executables. My name is Joris Kuipers. I work for Trifork in Amsterdam as the CTO and what I like to call a hands-on developer. I've been in the building custom enterprise applications with Java space for over 2 decades. And before this job, which I'm in for already over 10 years, I used to work for Spring Source. So I have quite a big background on working with Spring, teaching Spring. And that's also why I chose this topic. Actually, I know Arjen from an old assignment that we used to do together for another customer. For those of you not familiar with the term GraalVM, you may have heard it, but not know exactly what it is. GraalVM is a technology from Oracle that is actually more than just one thing. In the context of this talk, and also probably in the context for most of you in your day-to-day work, the most interesting part from GraalVM is something that they call the native image compiler. So it can take Java source code and it can produce, instead of Java bytecode with classes that you need to provide to a Java virtual machine that then interprets and runs them, it can produce a direct executable for Linux or Windows or Mac. It's going to be platform specific. It's other things as well. It's also like a whole language workbench. You can use GraalVM to have interoperability between code written in different languages, for example. It's also just a Java virtual machine and a compiler, so you can also run your bytecode on GraalVM. But the reason that most people are so enthusiastic about GraalVM, or that most Java developers are so enthusiastic about GraalVM nowadays, is for the native compiler options. So that native compilation means, as I mentioned, instead of producing bytecode, class files, and jars that will be on a class path and that will then be loaded by the Java virtual machine, we're going to basically have a tool that inspects the entire application, your code, all of the stuff that you happen to use on the class path, and it's going to do a whole bunch of analysis on that. And based on that, it's going to try to produce a highly optimized executable. What I mean with highly optimized, it tries to strip away everything that you don't actually need. Right? Classes that you never load, for example, will not actually be in the native executable. Also, it's limited in a certain sense of what it can do, because some of the highly dynamic aspects of Java, like dynamically loading additional classes that were not actually known at compile time, is something that a native executable will not be able to do. So there are some limitations there. So the reason is, why would you care, right? This stuff is still rather new. It's experimental. It can do some things, but certain other things that you are used to from Java are not actually available. There's basically 2 reasons that people are interested in this stuff. These native executables, first of all, have a super quick startup time. But if you start up a new Java virtual machine, cold start, and then need to start up something like, let's say, a Spring Hibernate application that then needs to load a whole bunch of different classes. It needs to dynamically reflect on them. It needs to create new classes based on that. That can easily take seconds, right, or tens of seconds. With a native executable, all of this stuff has basically been done at compile time. So what you will see is that startup time is measured in milliseconds rather than seconds. That makes it very interesting, because it means that there are now some new use cases where traditionally you wouldn't even consider to use Java, that now become available. For most enterprise developers, that will typically involve stuff like lambdas, for example. Right? You can write a function in Java, just have it spun up in some cloud provider whenever a request comes in. You would never think of starting a new Java application, including a JVM, to handle an individual request. Still, you may come from a place where you say, yeah, well, I don't really care. I write services that run 24/7. They start up. It might take a couple of seconds, but after that, they're there. So who cares about startup time? In that case, think about memory usage, because the amount of memory that you typically require when you run a native executable is a fraction of the same amount of memory that is used by running your application on the JVM. Right? And you can really, this can be like 10%, for example. It depends on a lot of different things. There is no absolute number where we say it's always this much less, but it will be a huge difference. And that means, for example, when you're running your code on a cloud provider, it's simply cheaper to run the same code, right? So you can run multiple instances of your application on a machine that has a lot less memory, or you can actually run multiple instances more than you were able to without this. So those are the reasons, the main reasons that people care about this stuff. Also, what you sometimes see mentioned, and that's especially when people from Oracle themselves are trying to evangelize this stuff, they say, yeah, it's also going to be much more secure. And they have a point there. But I don't think for many people that this will be a sufficient reason to actually move to a native executable. The reason it's more secure is that it cannot do a lot of things that Java can, a normal Java virtual machine, that could also be exploited. Stuff like dynamically loading classes has traditionally been a source of security exploits, right? There have been examples where people could, for example, use a web framework to do binding, right, to properties. So you have getters and setters. But then accidentally, they would allow to bind to the .class loader of a class, then change the actual URLs on the URL class loader to say this is where code should be read from, and then you trick the application into loading some non-existent JSP or something like that and says, oh, I need to load it from the class path. Let's go to this evil hacker server and download it. And all of a sudden you have external code running on your JVM, right? Serialization is another common example where Java serialization is problematic for many different reasons. But one of them is, again, that it brings in untrusted code. And none of that stuff actually works out of the box on a native executable. So, well, if you don't have it, it cannot be exploited. Right? Yeah?
How is this possible?
It's possible for a number of different reasons. I'm not an expert on this. So I don't have a definitive answer. But first of all, it's a lot of memory in Java itself is typically used by just classes being loaded and that sort of stuff, and that is not really there anymore. It also cuts away everything you don't actually need. There is still garbage collection, by the way, in case you were wondering about that. There is a garbage collection built in. It's a serial garbage collector by default. I think if you buy the enterprise version of GraalVM, you can actually get some other garbage collectors as well. It's not the same one that's used on a regular JVM, but it's there. So yeah, I think it's just because there are less moving parts. I think that's the main thing. But it's very impressive if you look at the numbers. And it's indeed, I think, for many reasons, a sufficient reason to be interested in it. It's also my main reason for being interested in this. A lot of the stuff that we build and do at DriveWorks still involves long-running services. So the startup times for me is nice, but it's, well, that's completely offset, as you will see, by the additional compile time that it takes to create a native image. But the memory usage is a very big reason.
How does the GraalVM compare to Hotspot VM? Because Hotspot has
JIT compiler.
Yeah. Not so much JIT compiler, but also optimizations. Which...
Yeah, it depends. In general, it performs comparably. So the people have done benchmarks and profiles on this stuff. Normally, the performance is very on par. There are some use cases for which running on the JVM might still produce faster results, especially for code that benefits a lot from the JIT compiler because it has certain behavior at runtime that cannot be foreseen by the compiler. So at runtime, it can do these optimizations. There are also, on the other hand, some cases where this thing already performs even better than the JVM. But in general, they are on the same level, and it wouldn't make a significant difference. Obviously, there might always be edge cases, but in general, from what I've seen, performance is just about the same. So that's not really a reason, indeed, to start using this.
And maybe a second question, how does this compare versus the work that is being done for Leiden?
Remind me what was in Leiden again? You have crack and
crack
stuff? Or,
and
yeah, that's very different. What they do for things like crack is, this is another technology that is aimed at startup times especially. It basically tries to create a snapshot of the memory that represents your Java application after startup. Because when it comes to things like starting up, people have profiled a lot. What is it that makes Java slow at starting up? Turns out that the majority of time is actually spent in class loading. Class loading has a very high overhead, typically only done at startup time. So Crack addresses that, but it has it's a very different technology. It doesn't do anything in terms of native compilation or anything like that. You still have bytecode, you still have the JVM.
I think the latest work, and the reason I'm asking, because the latest work in Leiden, they're also looking at not just a startup, but also running the hotspot several times where optimization is going to be baked in into class loading. So you will also get that.
Yeah, there are. If you dive deeper into it, you will find some overlap on some of these things, and also other JVMs. For example, my own services typically do not run on OpenJDK directly, but on J9 from IBM. They have similar optimizations where they can do this sort of stuff. Could also be interesting, for example, when you're running in constrained environments like Docker containers without a lot of memory. So there is some overlap, but it is quite different actually. And something like Crack, for example, for my sort of typical use case would not actually be that interesting. It just makes it harder and slower to run the thing. And the only thing I'm getting back is, a bit of a faster startup. But so the idea is that you're not, since you don't have a JVM anymore, as I mentioned, certain things are not there, simply are not there anymore at all. So there is no class path, right? You cannot dynamically load classes. Some other things, reflection, serialization, resource loading, by which I mean loading a file from a class path, for example. Those things can actually still happen in a native executable, but only when GraalVM knows that you want to know these things up front. So you cannot do reflection on arbitrary classes and find out about arbitrary things, like all of the constructors or methods or fields or something like that. But some things it is smart enough to actually figure out that, oh yeah, this is actually supported, and some other things will be supported as long as you tell GraalVM up front, and I'll show you this. Hey, I want to be able to do reflection on these and these things of these and these types. And it says, okay, I'll make sure that the metadata for those classes is actually included in the native executable. This, however, is sort of a problem for the typical enterprise frameworks because they rely on reflection for everything, basically, right? Yeah.
So, are you saying that Jackson doesn't work out of the box?
Yes, absolutely. Jackson is a great example of something that indeed Jackson hibernate when it needs to subclass and reflect on your entity classes, Spring. None of those things actually work by default out of the box with this.
Can you somehow say how much effort it is?
Yes, the idea is that for you, it's going to be no effort. Other people have actually spent the effort already, and that's actually what I'm going to demo. That's the ideal situation. Obviously, you may, and I have already run into some cases where this is not exactly true, but that's the hope. So we were talking about things like frameworks. Some frameworks, newer frameworks than Spring, things like Quarkus and Micronaut, they have already been built from the start with the idea that they want to try to avoid things like using reflection as much as possible. Because it gives you faster startup time, less memory usage. You don't have to do all of the caching of all of this reflection data, that sort of stuff. And that automatically makes them a little bit more suitable already for something like GraalVM. Spring Framework has been around for 20 years and doesn't have that head start from that point of view. So it uses reflection everywhere. But obviously, the Spring team has been very interested in getting support for this native executable inside of the framework. So a couple of years ago, they already started to investigate what type of approach should we even take to get this stuff working. They haven't done that in isolation. They have a very close collaboration with the GraalVM team at Oracle for this, which really helps. And after several iterations, they came up with an approach that seemed to work well. And the good news is that is now no longer like a separate experimental project, but that stuff has now actually been brought directly into Spring Boot 3, Spring Framework 6, and newer versions of that. But that's actually one of the major new themes and features for these new generations of the framework. It's the native compilation stuff. What they basically provide is a module that they call the AOT module, which stands for ahead of time. You will hear this term a lot when you start to read up on things like GraalVM native executables. Because basically what ahead of time means is that during compilation, so ahead of the runtime is basically what we're talking about here, there's going to be tooling that figures out exactly what your application needs to be able to do when it runs. It's going to try to figure out things like what classes will be loaded, but for Spring, also like what beans will be there, right? Spring has the concept of a bean, which is a managed object, an object created by Spring through reflection. It also has, in Spring Boot, has options like auto configuration. So it dynamically determines typically at startup time, okay, what is available on the class path, what is not there, what configuration do you have, what is actually missing? Oh, based on that, I'm going to automatically provide you with a bunch of stuff. That sort of thing, instead of happening at runtime, should now all happen during the build step of your application. And that's exactly what this AOT module actually does. How GraalVM works is when you run it, every library, basically every jar that you have or every piece of Java code can have a configuration file. It's a JSON file. And in that JSON file, you can tell GraalVM, hey, I want to be able to use serialization for this class. I want to be able to create dynamic proxies for that one. I want to be able to use reflection for that. It becomes a huge file typically. And basically, this AOT module will generate this stuff for you. So that's to your question, like with Jackson and stuff like that, this doesn't work out of the box. No, but they went through a lot of trouble to actually make sure that this will all be done for you so that you don't have to do it yourself for Spring, but also for all of the commonly used and supported frameworks in the ecosystem.
For Jackson framework, you can then bunch up all your TPOs into a package.
No, not really. I'll show you in the demo how it's sort of how it works. Yes. So what I will show in the demo is that the framework tries and sometimes or oftentimes will be able to derive what types should become available for use with Jackson. Then the AOT module will automatically create the metadata for that. But if it doesn't, for some reason, I'll show you a contrived example that I came up with. Then you will actually need to do some work to make sure that it works. That reflection data is basically available. That's what it boils down to. Also, and I can show you if we have some time actually what happens there. Spring itself normally does stuff like class path scanning when you start up your application, which is sort of inefficient in this sense. So it also rewrites the actual Spring configuration to use functional registrations of beans, which is not something you would typically want to do in your own code, but there is a lot of rewrite being done basically when you run this thing. When you want to use this, there's basically two ways of doing it. Either you run it directly on your machine or whatever machine the compile is running on, or the other way is you compile to a container. If I compile for a native platform, that means, first of all, I need to have GraalVM installed here. And because I'm on Windows, I also need to have Visual Studio installed in a recent version with a C++ compiler. It's great fun. Yesterday evening, I spent my evening installing Visual Studio and some updates to actually get that working. It works, but if I do this and I do create a build, I get a .exe file that only works on an x86 64-byte architecture on a Windows operating system. Not typically what we tend to run in the cloud. So to make sure that your build can actually always produce something that has the right type of executable. There's also support, as you will see in the plugins, to say I want to actually run my build in Docker. And then inside of that Docker, I just want to build a Linux image that I can use on the right architecture. I think, but I explicitly put in a disclaimer because I wasn't sure when I wrote the slides and I didn't want to look it up. I think you still need to be on the same CPU architecture. For example, if you're on a Mac with an M1 or an M2 chip, I don't think you can actually use this to build an executable that will run on an x86 architecture. But I'm not 100% sure. Doesn't really matter. What is very important to realize is that because now all of these choices have to be made during build time, Spring basically needs to take what they call a closed world assumption. I'm assuming that most of you are somewhat familiar with Spring Boot. Spring, for example, has the notion of a profile. When you start up an application, you can activate one or more profiles by name, typically through a system property or something. And then in your configuration, you can say this bean or this configuration class should only be loaded when this profile is active. Otherwise, just don't bother. So it becomes dynamic, right? People sometimes use this for different environments, or maybe if you want to run your application in a different way for multiple customers, something like that. That doesn't really work with this stuff because if Spring would want to support this, it means that it needs to know exactly what will happen for all of the different profiles that you could be able to activate, including all possible combinations, and all of the code for that would need to be included in the native executable, which would make it really bulky. It's even worse with something like Spring Boot auto configuration. If you look at how Spring Boot works, it has configuration classes for the whole world, basically, where it says, yeah, you know what, if you have that on a class path, oh, I'll automatically give you this. If it would need to include executable code for all of those optional dependencies, yeah, you would end up with executables that would be huge because it would have the entire open source ecosystem for which Spring has support. So it doesn't make any sense to do that. So instead, what happens when you run a build with this stuff, it basically starts up your application. Not fully, but it does load what they call all of the bean definitions. And based on that, it knows, okay, this is the stuff that will be used at runtime. This is what I will put in the native image. Everything else is simply not going to be there. That's an important distinction that you need to be very aware of if you are currently building applications and want to look into this stuff. Right? It's not necessarily a problem if you are aware of it early enough, but if you take like an existing application, I've seen teams, for example, using Spring profiles as a, I think, very heavyweight way of doing feature toggles. Right? If you would do that, it wouldn't work with this at all. It would be a very bad approach. So that's something you need to keep in mind. Now that's what I have in terms of slides. Because what I really want to do is I want to show you how this stuff works. And typically when people create a new application, they use something called the Spring Initializer. You can find this on the website, start.spring.io. It's also built in IntelliJ and Eclipse. You can say new project, do that. Inside of that, you can simply say, I want to have support for native. And when you do that, you get a project that has some additional dependencies in there. And I did exactly this, and I have such a project for you, which is over here. By the way, I am not going to apologize for running in a light team. I like to actually see stuff that I work on. So this is what I also use during the day. But I have zoomed in a little bit, just that you know that this is for you. It's not because I'm blind. So what do we have here? We have a Maven POM. It's just a Maven project. It uses a recent released version of Spring Boot, as you can see. And then I included an actuator, simply nice to have feature of Spring Boot, has nothing to do with the native stuff. I have Spring Web, so I have Spring MVC, and I have Tomcat as an embedded servlet container, test dependencies, and then something specifically targeting the native stuff. I have this native Maven plugin that you can see here. To that, just for this demo, I actually added this configuration setting. This is not included by default, where I pass this flag to the GraalVM compiler. This basically tells the compiler, be quick and not very optimized. So it does less optimization, which gives me more performance to actually run a build. You should not use this for production. You should use this for stuff like demos, because it's great for that. Or during development, when you want to get that quick feedback. And then there's the Spring Boot Maven plugin. So it's basically a standard Spring project, except for that plugin. Everything else is just default stuff. What do I have in here? I created a very simple Spring controller here, which simply retrieves a list of person objects, which is just a record with a name. And then it returns that when I go to /people. That's really all it does. You were talking about Jackson. Nice bridge. What this will do at runtime is this controller returns a list of person objects. And by default, it will run it through an HTTP message converter that uses Jackson to then say, oh yeah, I'm just turn the thing into JSON. This is what will happen. There's nothing here really. I just enabled the actuator endpoints, and that's pretty much it. So I could run this application normally. Right? I can just say, here, I want to run this thing on the JVM, and now it starts up as a normal application. Right? It takes a little bit because Java, slow. But now it's there in 2 seconds, and now I can open up a command prompt, and I can make an HTTP request, zoom in a bit, to, what did I call it here? To /people. So going back, this one. Oh, sorry. Messing around a bit here. And now I'm just going to get this list of person, right? This is what the application does. Nothing fancy there. What I'm going to do now is I'm going to compile this to a native image. So as I mentioned, to do that directly on the on Windows, I had to get some stuff in place, but I have that. So basically, you end up with GraalVM and Visual Studio C++ support. And then what I do is I can run this little script that calls Maven with a native profile. So that's important. We have to pass the -p native. And then there is a target called native compile. And when I run this, let's see, build native. This one is actually in the right directory already. Build native Windows. It starts to do this. And this takes a while. Right? What it first does is a normal build. And it runs the test as well, just on the JVM, as always. But after that, when that's successful, then it's going to kick in the AOT module. And that is now starting up a Spring application context, but not fully, but it does this to analyze what is actually there. Then it's going to download some stuff. I'll explain what this is in a moment. But this is basically GraalVM configuration for well-known open source frameworks that don't provide their own GraalVM support. And now it is busy generating my native executable. So this is a phased step. It's doing analysis, right? It's doing all sorts of stuff where it says, oh, you have this in place. Oh, I need to do something for that. I need to do something for that. I'm not even an expert, so I don't literally know exactly all of the things that are happening here. But this is basically all analysis aimed at producing an executable that has just enough information. And when it's done with that, it will actually run the next thing. As I mentioned, this takes a while. We'll see how often I'm able to do this during my talk as a demo. This is where it's now producing the results of the analysis. Now it's building the universe. It sounds really nice. And then eventually what you'll end up with is a .exe file in my target folder in a moment, which I'll show you. Yeah, the Java is stopped, so I'm not currently using the port anymore. So this should now start working, hopefully in a moment. It should, I think, be able to probably use all of them. Yeah.
Headshot.
Yeah. And again, like I said, because I'm not a compiler expert and I'm not aiming to ever become one either, I don't know exactly what all of these things are. But this is now done. Build a success. And you can see that it has now created this target Spring Native demo.exe. So I should be able to run that. Target Spring Native demo.exe. And now you can see it starts up, not in seconds, but this time not even that fast, but a lot faster. And I'm not going to show you what the memory usage now is also going to be very low, but it should be able to still respond to a request. So this is the happy flow, right? I just take my regular application. I don't do anything special. I just run a new Maven command and poof, I'm in native executable heaven. Fortunately, that's just not, unfortunately, I'm sorry. This is not exactly how it always worked. So I want to show you some things that Spring can do for you, but also some things it cannot. For that, I wrote something called my dynamic controller. This one uses reflection. The first thing I did when I prepared this demo is I wrote the first method here that says, you know what, I'm going to use reflection on the person, which is a record, extract the field names and return them as a list. And yeah, surely this will fail. And then I'm not actually going to demo it, but I could call this method now on my native executable. It would actually work just fine. And the reason that it works just fine is because I'm reflecting not just on any type, I'm reflecting on person. And if we go back to my simple controller, which is over here, then you can see that this thing actually returns a list of person. What that means is that the AOT module understands, but if you have a controller method that returns this object, yeah, it has to be run through some HTTP message converter, using Jackson in our case, could be something else. That probably needs to be able to use reflection on this thing. So what I'm going to do is I'm going to tell GraalVM, you need to be able to reflect on person. How does it do that? Actually, what you will see in my target, if I open it up, is there will be a Spring AOT folder here, and it has stuff in there. And this is the stuff. It has a resource config.json. And what you see here, not just a resource, also actually the reflect. This one, the resource config, tells GraalVM these are files that I should be able to load. Spring expects to be able to load application.properties from the class path, that sort of thing. Oh, you need to tell GraalVM about that thing. It also expects to be able to load a logback.xml file if you're using logback as a logging framework. Again, it needs to know about that stuff, otherwise it doesn't work. But if I look at the reflect config, this is where I can see reflection information. And a lot of this information here is about types that are not mine. Right here, it tells GraalVM how to reflect on the inner pool class of some task executor properties, whatever. I'm not even sure what this is. But if we look in here, you will also see my person here. And what it says is I should be able to use reflection to see declared fields, to see the declared constructors. These are the methods that are available that should also be there through reflections. All of this stuff is now available in my executable.
So did you just say that the one endpoint you created where you reflect on the properties just happens to work because you also have an endpoint that returns the actual...
That's exactly what I'm saying.
Yes.
I'm glad that I brought that point over.
So if you don't do that, you're screwed.
Yes, thank you for the bridge to the next demo, because obviously, exactly as you're saying, this is sort of a coincidence. Now, not literally a coincidence, because Spring actually says, hey, the typical use case for reflection is for stuff like controller returns, right? So I should be automatically tell GraalVM about this stuff. What I also did is I created another class, simply called internal person. It's a copy of the record, but it's not used anywhere. It's not in a method signature of a controller method or something like that. So Spring doesn't even know that this thing exists. And when it starts up the AOT module, still it doesn't know that this thing exists because this code is not actually executed during AOT. It just sees the bean definitions. It knows about method definitions and signatures, but it doesn't know about the code that's actually executing. So here, if I'm using the same code basically to say, give me all of the fields of the internal person, you will see it doesn't work automatically. I think if I went back to the right branch or commit, I should say, I should be able to actually show you this. So let me see. I think I still had something open, but whatever. 8080, internal person fields, empty array. In this case, it doesn't fail, it just doesn't see the thing. So it says, no, there are no fields. If I try to do other stuff, like reflectively invoke a constructor, for example, or the class for which there is no metadata available, it will actually fail. It says, hey, there is no default constructor method. And then you look at the class and you say, well, yes, there is. But well, the native executable doesn't know about that stuff. Very interesting error message that you can get that way.
You did not with Maven. You did a native build. Do you need to install specific things on your OS to make it possible? Like
for this to do it directly on the OS, yes, you do need to be able to do a compile for native executable code. So on Windows, that means apart from having GraalVM, because you always need that, obviously. It means installing Visual Code and then saying I want to have support for desktop C++ applications, and that gives you all of the right tools. On other operating systems, it means something else, but you definitely need to be able to run some compiler to produce a native executable, exactly. So that is also why there is this option of doing the same thing with Docker, which I'll show you in a moment. But let's get back to this first, otherwise we're showing everything at the same time. You can fix this, obviously. One way to fix this would be to write a JSON file like the one I just showed you. That's really not really an option. Right? You don't want to have to do that as a Java developer. What you want to be able to do is just do something in the code here to tell the AOT module, hey, make sure that I can actually reflect on this thing. I'm going to go out of order for my commits here. I'm going to show you the easy way first. The easy way is super simple. It's this one. Let's revert to this. Yes, there we go. Hard. So what I have now, when I go to my main class here, is I've added this line of code. You can see this register reflection for binding. This is an annotation purely intended for use with native compilation, and I can just list a bunch of types here. And I can not only put this on one class, I can put this on any configuration file basically that I have to register things. If I do this, and I now do a native build, you will see that inside of that JSON configuration file, it basically says I want to be able to do everything with internal person in terms of reflection. This may not always be what you need, or sometimes you may need to be able to configure other things than reflection metadata. Stuff like resource loading, stuff like serialization, stuff like proxy creation. So what you can also do is you can do this programmatically. And I have an example of that as well. Reset to here. What you'll see now is that instead of the annotation I had is I'm going to refer to a file. I'm going to say import this runtime hints. And this is a class that implements an interface called a runtime hints registrar. This is Springtime, which is just a functional interface, right? It's just one method that provides me with a hints type. And through that hints, as you can see here, I can programmatically configure certain things. So in this case, I'm saying on the reflection side, I want to register internal person. And then if you look at the method signature here, there is a var arc of member category enums. So in this case, I'm only interested in saying I just want to be able to see the declared fields because that will fix my particular demo application. But if I need more, then next to having declared fields, I can say I also want to be able to reflect on all of this other stuff. Next to reflection, there are other things I can do here. So I can also say I want to configure JNI. Great fun. Probably not relevant for regular application developers, as I assume most of you. But JNI is for interfacing with native code, right? Accessing memory outside of managed memory, that sort of stuff. Proxies means dynamic proxy generation. That is a form of dynamic class generation and loading. So not supported out of the box. You have to tell GraalVM that you're doing this for certain types. Resources has to do with loading resources, loading files. Right? That's the stuff I showed you that Spring automatically creates a file for. It says, oh yeah, of course, I need to be able to see application.properties, for example. But if you have your own custom files, you need to tell GraalVM about this. Again, only in certain conditions, right? Spring itself tries to really support you here. So for example, if you put a file in source main resources in your Maven layout, then the AOT module guesses you probably want to be able to load this file. So it will automatically register it for use with resource loading. But if it's somewhere else, you may need to do this yourself. So this is the alternative. Now, the hope of the community and of the Spring developer team is that this should really become exceptional, right? It's not the intention that you spend a lot of time doing this as a developer, because this would be horrible. Because you don't find out about that you need this stuff until you actually notice that, oh, fuck, my code doesn't actually work in the native executable. Oh, yeah, of course, I forgot to do this thing, right? Yeah, exactly. And you've also seen like what the edit run debug cycle will be when you have to include native compilation. It's worse than Scala. No, it is really slow. And actually, it is already a lot better. A couple of years ago, when they started this stuff, the GraalVM compiler was like, I think 10 times slower than this. And it's now way faster, and it's doing actually a lot more. It's more highly optimized. The results are really nice, but still, of course, this is going to be way, way slower than normal Java compilation. It will always be. So what I've seen so far, not many people are already using this in production with a lot of battle testing and hardened experience and that sort of thing. But I think what most people are doing is saying, well, to get that quick feedback cycle that we all know is super important when we're doing development, for local development and also for just producing maybe your developer build, we're just going to use normal Java compilation. We're going to run it on a JVM. Then we're going to have a build pipeline that says if we pass that stage, yeah, then we're going to go through the effort of doing native compilation and actually producing an executable. Still, that leaves you with this question like, yeah, but how do I know, right, that my code will then actually work in the native executable if I'm not testing it locally like that? Final thing I want to show you is that there is support for, well, in general, there is support in Spring for writing something that they call an integration test or a system test. That means starting up a Spring application context and then in the context of that running your tests. That's always been there. But what they've done is they've made it possible to take that, including a whole test runner, put that in a native image with your code, create an executable, and then run your unit test inside of the native executable to see if the executable code behaves as you would expect, just like the normal Java code would.
I thought you were going to say you can add it to the AOT.
That is, it happens, but there is more. So it is in the AOT, but on top of that, they basically make sure that when you start up this native executable now, it runs your tests. And this is what I'm actually going to demo because it may sound a little bit.
That's way later in the process.
Yes, that is later. So it's both. It is also included in the AOT because it needs to be, otherwise it's not there. But there is some additional stuff that it does to actually make sure that the whole thing that it produces is not just your application, it's your application with all of the tests. That can be executed by a test runner that needs to be part of the native executable because, well, there's nothing else. Right? So I have an example of this. So what I did is I wrote a test. Not in this commit, but I did write a test. So let's go to this branch. And there we go. What I do here is I create what they call a slice test in Spring Boot. So it's a test that doesn't bootstrap the entire Spring Boot application, but says I'm just going to bootstrap the stuff I need for Spring MVC. I want to test that controller. And then I'm going to use a mock MVC to fake making an HTTP request, in this case to this internal person fields. And then what I expect is some JSON contents, which is an array that should look like this. Now, when I run this now, this will just work. And because my code does this. So this should be green, hopefully. Otherwise, I'm not sure what happens. And it's green. Now, this is not in my native executable yet, because of course, when I ran the build, I wasn't on this branch. So what I could do now, let me go here, stop this. Yes. What I have here is a command. I don't remember this stuff, so I create commands for everything. That says run Maven with the native test profile, and then do the test. And it looks very innocent, but when you run this, it again takes a very long time because it's going to again do a full native compile, then produce an executable, and then run that to actually verify that stuff is now working. And if I am, let me verify, but what I did to make the test fail is when I go back here, you can see that I commented out this register reflection binding, right? So I'm missing the stuff that I actually need to be able to see the fields. And in this case, although it will take a while, the test eventually should be able to see that. Yeah.
So is there a difference between the optimization level you choose?
The optimizations, from what I gather, have to do with how many classes are being analyzed by the GraalVM compiler to do a optimized analysis of what it can strip away. So I think what you will end up with is especially a bigger executable. But because I'm not a GraalVM
so what I mean is that if you run the test at say level 0,
yeah,
and then compile your production code for level infinite, does it then still at runtime?
It is a different executable, but I don't think it should matter for testing if functionally your code will still do what it's supposed to do. Because you're not testing if the GraalVM compiler works correctly. You're going to assume that it does. You're going to test if it has been provided with all the necessary configuration instructions. That shouldn't matter if you do like low or high optimization levels. But again, I'm not talking out of experience. I'm talking out of this is how it should work, right, obviously. It failed. And let's see how it failed. Ooh, JUnit said, failed to discover test. This is not what I got when I tested this yesterday. Let me just assure you, when I fix this, it will actually work. I have seen this working. I'm not sure why it's breaking now. But again, because this stuff is taking forever, I'm not going to try to live debug this in front of an audience. What I want to say, though, this is an example of how new and experimental this stuff still is. Because I did all of this stuff yesterday evening, because I like getting a deadline to get the work done. When I wrote this test yesterday, my original test was not saying do content.json. My original test was actually using a JSON path expression. JSON path is using a library from a company called JWay to evaluate a JSON path expression. And I had a $.length, and I was then evaluating if the length was 2. And that was a really nice test. It worked on the JVM, and then I tried to do it with native executable. Then it says, I don't have the length class's initializer, so I cannot actually evaluate this expression. And that's simply metadata missing that the framework that when you run it with this native test profile doesn't know that apparently oh, I'm also using JSON path, and to actually use JSON path in a native executable, it also needs to be able to reflect on certain expression evaluations that map onto a class inside of the library. Now, this is not stuff I want to think about as an application developer, right? So this is stuff that eventually will be fixed, but it will take some time. On that, fixing stuff, I showed you already in the target folder that there is this Spring AOT, right? So if you remember, what we had here was these files for my application. Now, I don't just need this for my application. I need this for everything that I'm using, right? All my third-party frameworks and stuff like that. Now, since this is early days, there are some frameworks that already provide this sort of information by themselves, but not too many. Spring does it, Micronaut does it, Quarkus does it, because they're really focused on this stuff. But most of the just regular open source libraries that we all love and use do not do this yet. For that, there is a community effort. Let me see where one of my tabs has this. But of course, oh, I don't have internet, but it might still be there. Let's see if I can show you this. Otherwise, I'm just going to tell you this stuff that I want to show you. Is it this one? No, this is Hibernate. This, by the way, very different topic, but if any of you are planning or working on migrating their Spring applications to Spring Boot 3 and you're using Hibernate, prepare for a world of hurt, just so that you know.
Just drop Hibernate.
That would also be an option. This is again more Hibernate.
Probably easier.
Here it is. This is what I was looking for. I'm just not sure if yes, I do actually get some stuff here. What you see here is a GraalVM page that says these are all of the libraries and frameworks that are supported with GraalVM. But the interesting bits here are all of the things that have this little one superscript here. Because let me zoom in a little bit. If you scroll down and look at what does the one mean?
Maybe.
It says, no, not maybe. It says requires metadata from the GraalVM reachability metadata repository. This is open source community repository, basically, where people can provide metadata configuration for frameworks that do not provide it themselves. And actually, the Spring team has been really active on this stuff. So you can see it here. This is the repo. And you can see all of these projects. For example, Jackson. And if we look at Jackson, then we can see that there is this reflect config.json. And it says, oh yeah, enable for to be able to use Jackson, I need to be able to do all of this stuff for the Jackson internal classes. Right? But Jackson doesn't provide this itself yet. The expectation is that when this thing will become as popular as I think it will probably going to be, libraries and supporters and maintainers will start to add this stuff themselves and take responsibility for this, but it's just too early days. So a lot of this stuff is provided here, and frameworks like Spring, Micronaut, and Quarkus actively use this stuff. So actually, when you do a native build, it downloads this entire repository. And that's what I can show you, because if I look in my IntelliJ here, you can see that next to this target Spring AOT, there is also a target GraalVM reachability metadata. It's really just that repository. You can even see the Git commit that it checked out, right? And this is just all of that stuff. So this is all there. This is not stuff I'm actually using, right? I'm not doing anything with most of these things in my demo project, but it just downloads everything just in case it does need it and provides it to GraalVM. So that's always there, basically. From this GitHub repo here. It's just downloaded. Yes, the first time, yeah, after that it will probably be cached, but yes, you do need to be online. I don't know. I haven't tried. I wouldn't know what happens then. Maybe, yeah, that does make sense, because this would be a common concern for a lot of companies, that they say, yeah, sure, but Maven Central, no way. So you can probably proxy it somehow, indeed. But since I really have no experience with this in any sort of production environment yet, I wouldn't know what the best way is to address that. But I'm sure they have covered it, because it's a very good question, because it's a very common use case. So, but I'm sure there will be a way to do that. Yeah. Let's say, so, and the final thing I wanted to show you, I'll start it up and then open up for questions while it's running, is this Dockerized build. Because like I said, typically, I wouldn't really care that much about being able to create Windows executables, right? Who am I going to impress with a Windows executable? It's not typically how it's done. So what we have here also is this build native container command. And again, what it does is very simple. It executes the same, it uses the same Maven profile called this native profile, but then it does build image. And this thing uses a project called build packs. You may be familiar with that. This is not necessarily related to native image at all. You can also do this without the native image. And then Spring Boot will create a highly optimized Docker image for you using best practices. What does it mean, best practices? Well, for example, instead of just creating a fat jar and stuffing the jar in the Docker image, it actually extracts it and then adds different parts to different Docker image layers so that all of your third-party dependencies are in one layer, and then all of your application classes are in a higher layer. So if only your code changes, it only needs to upload the delta, basically just that layer, and everything else can be cached. So it will be way faster to upload stuff to your Docker image repositories. It will be faster to download things as well if you already have everything else downloaded, like the base image plus the third-party dependencies. All of that stuff is automatically done when you run this. But let me just execute it. And what will now happen is actually performs my build in Docker. So the end result of this build will be a new Docker image stored in my local Docker repository. And then I can just start it up, and it will start up the application running in Docker as a Linux executable.
Writing a Docker file or anything?
Yes, that's that part. So not having to write a Docker file and still getting a Docker image, that is completely handled by build packs. And that is unrelated to the native executable. This is just a different feature that Spring Boot happens to provide for quite a while already. Of course, for normal applications, you can also opt out of that and say, I want to write my own Docker file, which is actually what I'm doing. But especially for this, it's super convenient that you can just say, just do this. Because normally the reason for having your own Docker file is stuff like, yeah, I need to choose a base image and what Java distribution and what else. There is no Java runtime anymore when you create a native executable, right? So it's going to be like this super tiny, highly optimized Docker image. So that's actually kind of nice. Yeah, that's. I think that's what I have time for, and that's what I wanted to show you. Let this thing run, and I'll start it up when it's done, just to prove that it actually works. In the meantime, are there any other questions that you would like to ask? Yeah.
Can you grab the?
Oh yeah, it's really. I can also repeat the question. This is fine.
So all these frameworks now provide these JSON files with all the files they possibly could be using at runtime.
Yes.
Won't this be way too eager?
Honestly, I don't know. It's a good question. The obvious answer, it depends. In the sense that many frameworks will know exactly what they need for normal execution. But with some of these other libraries, yeah, they may be doing way more stuff than what your application is actually requiring you to have. But it's still the case that, as far as I understand this stuff, even if you provide GraalVM with these configurations, say this should be there, if GraalVM sees that you're never ever going to even have that class available, for example, I don't think it will actually do anything with this. But in general, I think you make a very fair point. And this is, I think, also one of the things that people are currently working on improving. Getting the size of the native executables down even further than what it is already is definitely one of the goals of both the GraalVM team itself, as well as the teams doing this sort of work on top of it, like the Spring AOT modules and what Quarkus and Micronaut are doing. So yeah, there is definitely room for more improvement here, because even though this is now production ready in the sense that this is now part of the core frameworks, right? And there is active support for this. This is no longer experimental. It's still very early days. And yeah, you may run into things that don't work, that will either just hopefully fail really hard, or might actually fail silently, like my demo, right? I'm using reflection, give me the fields. It says, yeah, there are no fields. It doesn't say, I don't have reflection metadata, which would be nice, because then at least you would notice. No, it just produces a wrong result, right? So for now, we're in the phase of evaluating this stuff. I've already seen that for a lot of services that we build, where we're not doing like any exotic stuff or a lot of reflection ourselves, indeed, just running a native build without making any changes seems to just work. But to actually know that seems to just work means I'll just put this in production and I'll sleep happily. That's a little step in between that still needs to be taken. But I have really high hopes for this because I think it's extremely cool that we now get two things. We get the small executables and the very little overhead of memory that people who are doing stuff like Go and Rust are already accustomed to. And you get this completely new way of using Java for stuff like lambdas that simply wasn't like even an option to consider writing your code in Java 4 in the past. And well, since I've been doing Java for more than 20 years already, I kind of like being able to just get my shit done in Java, right? So this is like a whole new era almost, where JVM will still be there. And this is, I don't think anyone is intending this like as a replacement for it, but it gives you this whole new alternative way of doing it for cases where it makes sense. I think that's how you should look at this. That's my talk. So yeah.
I have still one question. The last command that you ran, data image.
Yeah.
You can also run it without the native profile, right?
Yes, absolutely, absolutely. So that's what I was saying, that the build pack support is completely separate, orthogonal concern, to the native executable. So indeed, if I'm not using the native profile, this will just produce a normal
Docker image
with a JVM.
with the JVM. That's bigger than you.
Yes, exactly. So yes, that is there. And that option has been there for a while already. And that's actually a really nice one if you don't want to write your own Docker files. If you do want to write your own Docker files, by the way, I like explaining stuff. Sorry. There is also, you can still have this highly optimized layered image. That's actually a built-in feature. When you have a fat jar, Spring Boot jar, there is built-in information in there on how it should be extracted into layers. And when you start it up with a certain command, it will extract itself into directories that you can then simply do docker add, docker add, docker add, docker add. Docker copy is actually what you should be using in your Docker file. And that's exactly how I'm currently building my Docker images for my own project. I'm doing literally this, and it's super nice. It's when we do a build, I have like 30 microservices in a mono repo, in a mono build. If I do a build and I change one class on one service, then first I use Gradle, which is really good at caching and avoiding stuff that it doesn't need to do. So the whole build itself is really quick. But then also creating the Docker images and uploading them is super quick, because those things are completely the same if nothing has changed, literally byte by byte. So you will see this push to this remote Docker repo, and it says, oh, cache, 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 cache. Oh, I don't have to do anything. It's basically just retagging. So it becomes highly efficient to do this sort of stuff. So we can do a build of 30 plus microservices in 2 minutes if I don't make a lot of changes in my code. So that's actually really nice that you can do this sort of stuff. So here, now that we have this, right, just to prove that it works, I can say docker run. Ooh, look at that. I think I did this before. And now I'm running this thing in Docker. And again, it starts up really quickly. And now even quicker because this is Linux and not Windows. No, it's actually simulated Linux. No, it's also not simulated because there is a Linux kernel in Windows nowadays. Really cool. But this is all I had. So thank you. And that was it.